Yes, sir.
So we will start with that remaining stuff of the prompt engineering. So we were looking on this chain part. So we will start with combining chains. Uh, yeah, these are the objectives. Just a quick recap. Chains are composed of several runnables. Runnables are nothing but the unit of work that can be invoked or that can be batched or that can be streamed. Multiple runnables can be clubbed with the help of that pipe symbol, and we will form this, and we will call this as a chain. We can call these functions such as invoke, batch, stream on runnable. So definitely we would also be able to call these functions such as batch, invoke, and stream on chain also. Okay. Here we will have a look at how can we compose multiple chains. Fine. So here we are importing this chat NVIDIA chat prompt template, string parallel, runnable parallel and runnable lambda. We know that what is the meaning of this or what is the significance of this runnable lambda? Runnable lambda is used to convert a simple Python function into a runnable, right? Then it is nothing but creating the model instance, and here we are defining the same model. After that, this is nothing but the chat NVIDIA class. Here we are defining this base URL and model. Now what we need to do, this is nothing but one Python list. In this Python list, the name of this Python list is thesis statement. Here multiple thesis statements are given, like this is nothing but the first statement, then second statement, followed by third, fourth, fifth. So total five statements are there. Then we are creating one chain. This chain is regarding that performing spelling and grammatical mistakes removal on the input. So here we can see this is nothing but my template, chat from template. Here I am writing this instruction. Fix any spelling and grammatical issues in the format in the following text. Return back the corrected text and only return the corrected text with no additional comments or preface. And here I am providing this text, right? Then I am having a string output parser. After that, I am clubbing this three runnables into chain. This is nothing but the first runnable, which is nothing but template, prompt template by which we can generate the template by defining the input value of this text. Then second LLM is there. Prompt is generated. It is given to LLM. The response of LLM is given to parser, and we call this as grammar chain. Now, multiple statements are there in the thesis. So we need to call the batch method on grammar chain, and we just pass this thesis statement. Here in this corrected text, we are collecting the inputs. So for corrected text, in corrected text, print this, right? Now we are creating second chain. The name of this chain is paragraph generator chain. Name of the second chain is paragraph generator chain. So what is the meaning of this paragraph generator chain? For each of these sentence in the thesis statements, we need to generate one paragraph. Now see, this is the template I am defining next time. Chat from template. I am writing this. Generate a 4 to 8 sentence paragraph that begin with the following thesis statements. Return back the paragraph and only the paragraph with no additional comments or preface. This is important. We need to generate a paragraph that begin with the following sentence. Okay, and here we are providing thesis statement is equal to this thesis. I'm interested in generating the paragraph such that the first sentence of that paragraph is this statement only, right? Then once again we are clubbing these runnables. First one is this template for generating the paragraph, in which we need to provide the value of this thesis, which is passed to LLM. Then LLM will generate the paragraph, and then finally it is given to parser, and then we are having this uh, variable in which we are collecting the results like paragraph generator chain. Then we need to call the batch method on thesis statements. So all these statements are provided over here and it is collected into this paragraph. Then for paragraph in paragraph is equal to fine. So we are printing all these paragraphs. Now so far we have defined two chains. First one is this spelling and grammar chain, and second one is paragraph generator chain. Now ultimately what we want, if you thesis statements. So these are the thesis statements. Here we can see grammatical mistakes are there. For example, the fundamental concept quantum physics. Like, see, this is not correct. What it should be the fundamental concept of quantum physics. So of is missing over here. This of is missing over here. Actually, it comes under that grammatical mistakes. So ultimately, we are having two chains now. First chain is corresponding to removal of that spelling and grammatical mistakes, and second chain is corresponding to generation. What we want, first of all, this grammatical and spelling mistake should be removed. After removal of grammatical and spelling mistake, this is given to paragraph generator chain. Fine. So here our aim is to club these two chain first. How can we club? So here this is nothing but first grammar chain. It just remove all this spelling and grammatical mistake and and then finally the outcome of this is given to paragraph generator chain, and we are calling this chain as corrected grammar chain. After that, yeah, we can see the ASCII graph for this, and then we can call or we can invoke the batch method on corrected grammar chain by providing the thesis statements. So all this thesis statement will first go through this chain, grammar chain, which will just remove all the spelling and grammatical mistake. After removal of all these things, it is given to paragraph generator chain, and then paragraphs are generated, and finally it is collected in these paragraphs. So here, like in this line, actually most of the things are clear. For example, this is nothing but grammar chain. This is a simple chain. This is nothing but another chain. Both of these chains are composed of runnables, right? And we are clubbing these two chain by once again this symbol, pipe symbol, and this is nothing but the clubbing two chain. So on this club chain also we can call this batch method. We can call invoke method, right? Fine. Next we are having this parallel chain. Here we will see this parallel chain. Suppose here we can see two chains are there. which are clubbed in sequential manner. For example, this is the first chain and then this is the second chain. First chain is getting executed and the outcome of first chain is given to as input to second chain. But suppose if we are having such kind of necessity in which both of these chains should be executed in parallel. So how can we do this? For that we are having this runnable parallel with us. What this runnable parallel will do, it will this create this model like base URL model and LLM. Then we are having parallel chain execution. For example, this is the input that we are interested in processing. For example, this is the large language model with prompt engineering. Okay. Now this text is there. On this text, we are interested in performing two things. First one is converting it into title case. Just like that, like all these words, the first letter of these words will become capital. Okay. It is nothing but conversion of this into title case. And second one is counting the number of words the text contain. Fine. So these are the two operations that we are interested in performing on this. Now we are having constructing parallel runnables. So this is nothing but the first runnable. Lambda is simply defining one function. So what this function is mapping? This function is mapping from text to text.title. Which whatever text we provide over here, this text is converted into text.title. This mapping is converted. This is simple one mapping in the form of function only. Here this is converted into runnable by applying runnable lambda, and we call this as title case, right? Then we are having similarly word count. Word count is another mapping in which text is mapped to this, uh, counting the number of words. So it is like that. The first one is text and it is mapped to title case. Then second one is text and it is mapped to text dot split. For example, the length of the text, how many words are there. So this will become two runnables. First one is title case and second runnable is count word. We can see the outcome. So I have just missed this cell. Now see, when I am calling invoke method, because it is the runnable now, right? So I can call the invoke method on title case by providing this text and then printing the title. So it is just converting this into title case. Look at this. This is the title case. Every character of the first of each word is in caps. Then I am having this word count, calling the invoke method on count word by providing this text as input. So this will become word count 7. Now I am clubbing these two runnables. So this is the first one, title case, and it is nothing but the count word. It is called serial chain. Why it is called serial chain? Because first of all, this title case would work. Whatever input we are having, it will convert that into title case, and then the outcome of this is given as input to count words, which will just calculate the number of words in that sentence. Fine. See the outcome of this. Outcome is simply 7. But along with this 7, if I want this outcome also, for example, this one, this outcome is not get, I am not getting this outcome because that is nothing but the serial chain. So along with this 7, if my application also demand that the title case should also be there, I need to perform some other operation on that title case and I need to also perform on the count. So I should have both. If this is the requirement, then I should have this parallel runnable. Then I can have this parallel runnable. See what is the meaning of this? I just need to apply this runnable parallel, and here I am defining this first runnable is title case and second runnable is count word. Okay. Now I'm just invoking, I'm calling the invoke method on parallel chain by providing this text. Okay. So this title is printed like that, and word count is, this title is nothing but simply some variable. For example, I have just changed this. Look at this. This is nothing but the name that we are providing, and word count is this. So this title case is runnable, and this is simply the variable that we are defining, right? Another simply this count word is nothing but the runnable, and this is the variable that just change it. Okay. We can also see the ASCII graph for this. So here we will see some parallel executions are there. For example, the first lambda is regarding converting that into title case, and second lambda is corresponding to counting the number of words. So these are nothing but the parallel things. We can also use these parallel outcomes. For this is my mapping. X is there, and I'm just printing this string like X of title has these many word count words. Okay, and just converting this simple mapping into this runnable by defining by applying runnable lambda on this, and I'm describing this as describe title. I'm calling the invoke method by applying or by passing both of these title and word count. So it is printing like this, like building large language model with prompt engineering has 7 words. Fine. So this will become my final chain when I am clubbing parallel chain and describe title. We can see the ASCII graph for this. It is nothing but the sequential chain, parallel chain and describing title. So first we can see this is the parallel chain. Fine. This parallel chain is given as input to the next lambda, and then we can have the outcome. So we are having this final chain. We can call invoke method on this. So it is nothing but this type of outcome is printed. Ultimately, we are having both the outcomes, and we are also using both the outcomes in some downstream task. Now here what we are interested in demonstrating that describing literal syntax for parallel runnables. So here what we are doing, this is nothing but my final chain by applying runnable on this title case and word count followed by describe title. Now, yeah, this was the same thing. It was my parallel chain. See, it indicates that I am unable to call the invoke method on parallel chain. The takeaway is important over here that it is always safe using runnable parallel, even if you prefer the dictionary literal syntax. Use runnable parallel when the Python interpreter would not be able to understand that your runnable is not empty, is not simply a Python dictionary. Because here we have not used the runnable for parallel chain. That's why we are getting error when I am calling the invoke method on parallel chain. Next, this is the simple exercise in which we need to create a chain with parallel LLM task. So these are the various statements. It is just a simple Python list. 5 statements are there in this list. Here we have to generate like 3 things for this. First one is this sentiment template. For each of these sentence, like in a single words, either positive or negative, provide the overall sentiment of the positive following piece of text. So this template is regarding that sentiment template. Second template is regarding that main topic template, and third template is regarding that follow-up questions. Okay, so templates are defined. Next, we are having this output parser. Now, finally, a custom runnable which expect a dictionary as four inputs. For example, statement, sentiment, main topic, and follow-up. Like this is nothing but the runnable lambda. Okay, and here we are just having mapping from this response to this first statement, then sentiment, and then main topic, and then finally follow-up questions. So this is my output formatter. Now look at this, what we are interested in doing. The input is like this: statement to formatted output mapping. This type of things is there. Okay. So here we can you can go through this. This is given over here. Also, we will just go through this very quickly, and then we can start some other stuff. These are the three sentiment chains: sentiment template, LLM, and parser. Three chains are there. Then this is nothing but the parallel chain. We are applying runnable parallel because we want the outcome of all these three, right? Parallel chain. Then it is nothing but another chain in which first runnable is preparation for template, then parallel chain, and then output formatter. We can see the ASCII graph for this. Then I am invoking the batch method on this chain, and this is the outcome which I needs to print. Fine. Okay. So now we will have a look at third one, which is nothing but prompting with messages. Okay. This is important here because it is used for designing chatbots and all. So here two types of messages are there: human message and AI message, which are demonstrated in notebook number 31. Second one very important prompting technique is called few shot prompting, which is demonstrated in 32. Then system messages are there, which are demonstrated in 33. Then chain of thought prompting in 34. Reasoning models are there in 35, and chatbots are there in 36. Okay. So we start with the first one, that is human and AI message. I just call this like run all cell. Then see here, this is nothing but we are importing all these things. For example, chat NVIDIA chat prompt template, few short chat message prompt template. We will not use this few short chat message prompt template in this notebook, but anyway, we are importing this like struct output parser, human message, and AI message. Now we need to create a base model instance. For example, by providing this base URL and model. So base URL is equal to this base URL, model is equal to model, and temperature is equal to 0, and it is passed to LLM. Then we are having this chat messages. So suppose I'm having this various kind of chat messages. So what do we mean by chatting? I am asking something to LLM. So and in response of that, LLM is generating some outcome. Okay. Then once again I am asking another follow up questions to LLM. Then LLM is generating something. Fine. So this is nothing but the chat or conversation between me and LLM. Here, what is there? First, we are defining the prompt. Sorry, first we are defining the template, and we are using this chat prompt template and calling this method from template by, and then this is the placeholder message. We are expecting the input of this value prompt into this template. Then we are calling the invoke method on this template, and prompt is saying hello. Okay. So from this template, we are generating this prompt, and this is nothing but the prompt. When I'm printing the prompt, what is this prompt? This prompt is nothing but chat prompt value. This is important. It is nothing but chat prompt value. Fine. And which messages are there in this? Like, what is the message here? If you look at this message is equal to, if you look at this message is equal to human message is there. For example, message is equal to this human message. And what is the content here? Content is this hello, and these are some metadata like additional informations are there. Not interested. We are not interested in this. Fine. So here we can see it is one message. Here it is also written that which type of message is this? It is a human message, and all this comes under what? Chat prompt value. Fine. So far, we have not interacted with LLM. We have simply called the invoke method on template. When invoke method is called on template, then prompt is generated. Next, we are having two messages. With the help of this, we can also print like which type of human messages or which type of message is this. Fine. So we can see here human message content, and these things is printed over here. See this message or this method to message. Simply print this thing from here. It is printing this one. When I'm calling this to message on this prompt, then this is printed like only like which type of message is this and what is the content. Next one is AI message. Then this prompt template is clubbed with LLM. We apply the value of the prompt in this prompt template. Prompt is generated, prompt is given to LLM, and it is nothing but the chain. Next, I am calling the invoke method on this chain, and I am just applying prompt is equal to hello. So I am saying hello. I am saying this hello to LLM. LLM is generating the response, and then that response is printed over here. Look at this. What is that response? Response is this. First, it is printed like AI message. Why AI message? Because this response is generated by LLM. That's why here AI message is printed. Now, what is the content here? Content is nothing but this hello. Is there anything I can help you with or without? Fine. So this is what said by LLM only, and these are all additional metadata information. We can also print over here that we can also append the parser. So we will just get the content here. But anyway, we purposefully we have not written that parser because we are interested in this AI message. Then we are having explicit role use in prompt. So far we have not defined like any role in the template. This time we are interested in defining that. For example, it is chat prompt template dot from messages. Okay. So then from messages is nothing but the method, and here I am defining expecting the prompt. And see from whom I am expecting this prompt, from human. That's why it is written like human message is there. So what we are doing here, we are using this role in this prompt. Then we are having this chat prompt template from messages. So this is nothing but chat prompt template from messages. Here I am writing human and this prompt is there. Can you see the difference here? So far we have used this from template, okay, and there we are just expecting the value of any specific placeholder without defining this like human or AI. But here I am generating or I am defining this template, and in this template we are expecting that okay, this type of data is this, and what is the role of or what is the type of this message. So that's why here it is written that human, and then this is the prompt. Now here I am expecting the value of this prompt is hello. I am expecting the value of this prompt is hello. So this will become prompt template. This will become prompt template. I am calling the invoke method on the prompt template by up and then providing the value of this prompt is equal to hello. So this will become prompt and then printing this prompt. Can you see this like chat prompt template message hello content? It is exactly the same thing. If you look at this previous history, exactly same. Here I am defining this chat prompt template, but here I am calling from template method. Okay, here I need to just provide simply prompt as input. Here I do not need to provide whether human is saying or AI is saying something. Okay, but in from when we are using from message, in that from message we need to define that find key whether it is human or AI like that, because message from message we are generating the uh, prompt. So we need to define like which type of message is this, whether it is human message or whether it is AI message. And exactly same thing is happening over here. See here, prompt is generated from this template and this is printed. Chat prompt value message human message content is equal to hello. Exactly same thing is printed when I am using from method from message instead of from template over here. See this one. Chat prompt value message human message and content is hello. We can also print like two messages, so I am just printing here which type of message is this. So here human message is this. So the thing or the conclusion is that I can use this from template, I can use this from messages also. Difference is that in from template I need not provide that which type of message is this, because I am not using from messages. But in from messages we need to define clearly which type of message I am interested in using. Here I can also pass fine same thing I am doing over here, that clubbing this prompt template to LLM and in the form of chain, then calling the invoke method by passing the value of this prompt is hello, and then response is generated. So when response is generated, exactly same thing is happening here which was happening previously. The response is coming under this AI message because this response is generated by LLM. That's why the type of this message is AI message. And what is the content? Hello. Is there something I can help you, or would you like to chat? Okay, so this is the outcome which is generated. Next, using chat prompt messages directly. So what do we mean by that? We can simply use this chat prompt template from messages. We are using this human is equal to prompt. Instead of that, we can directly use this like chat prompt template. Simply write chat prompt template and human is equal to this prompt. So just look at this. These are exactly the same thing. See, the outcome of this cell number 17, and the outcome of this cell number 18 is exactly same. Both are chat prompt template. Input variable is prompt and message is equal to human message. Fine. So yeah, chat prompt template dot from message. We can simply write chat prompt template. It is important. We will primarily use from messages in this workshop primarily because we expect you to see it much in documentation and literature. But anyway, we can use this without that also. Next one is this, create an explicit human message. What we want. Here I am defining this from template, chat from template. Give the concise etymology of the following English words, and here I am providing these words. Fine. This is my template. Then a string output parser is there, followed by defining the chain, template, followed by LLM, and then parser. And then we are calling the invoke method on this chain by providing the word learning. So it is just giving me this outcome. The word learning comes from the old literature, word learning. Fine. Now see the solution. What was the exercise? Create an explicit human message. Here the things are done with the help of from template. Okay. This time we are interested in doing the same things with the help of from messages. How can we do this? Chat prompt template from messages. Here we need to provide this human message, and here this is the things. Again, expecting the input word. Here also, when I am using chat prompt template from template, here I am expecting the words, the value of this word input, or the value of this input word. Here also the same thing is happening, but only difference is that as I am using from messages, so I need to provide that this comes under human message. Then parser is there, string output parser. Then template is there, template is concatenated with LLM, and then parser, and then this words. So here what we have seen, here we have seen that explicit human message we are using. Now we will try to see explicit use of AI role. Any query or any doubt till this point? So here I am defining this from messages once again. Now see, this is the first message. Hello is said. Hello is said, and the type of this message is human message. Then AI is generating this stuff like hello, how are you? The type is AI message, and after that, human is saying something in the prompt. So this is nothing but the template. When I am invoking this template, then I am expecting the value of this input prompt. Fine, just see here. So I'm calling the invoke method on this template, and by passing the value of this prompt, I am well, thanks. Then I'm interested in this prompt. So three messages would be there. First one is this human message, second AI message, and third one is once again human message. So when I'm printing, when I'm calling this method, two messages on this prompt, so it is giving me like three answers. First one is this human message, content is hello. Second one is AI message, the content is hello, how are you? And third one is again human message. It is saying that I am well, thanks, right? So far we have seen that how we are defining the messages. Simply I am writing this, I am using this from messages. On this from messages, I am defining this is the content, and the type of this is human. And then next one is this content, and the type is this hello. After that, the value which we are expecting is as prompt, and then it is nothing but human one. Instead of defining this, we can also do another optional things, which is nothing but this, like importing human message and AI message. Importing human message and AI message. So this is one and the same thing. Cell number 30 and cell number 32. Look at this, cell number 30 and cell number 32. In cell number 30, we are simply defining this stuff, uh, that hello is there message, and the type of this message is human. Instead of that, we are using this human message instance of that human message class. Fine. Here we are passing content is equal to hello. Then we are having AI message content is equal to hello, how are you? So these two are exactly same. For example, I can write this also, uh, double quotes human, then double quotes hello, type of the message, content of the message. Optionally, otherwise we can also write this one, like human message, and then content is so these are one and the same thing. Here we are explicitly using these classes, and which are these classes? Human message and AI messages. Fine. So this is all about the summary of human and AI messages. Fine. Any doubt or any query till this point? Then next we are having this few shot prompting. So we are having this few shot prompting. Few shot prompting and chain of thought prompting is very important. So yeah, we will try to understand this few shot prompting now. As the name suggests, few shot indicate that some example that we will include in prompting. So far we are just giving the instructions. We want that in addition to these instructions, we will give some examples. Okay. Then here we will see observe and affect the limitations of few shot prompting techniques. And then we will see efficient creating and editing the few shot prompt. So just click on run all cell. Here we are importing this stuff, chat NVIDIA chat prompt template, few shot chat message template, and string output parser. Then we are having this model instance. So this is my base URL and model I am defining. Then chat NVIDIA is nothing but the class. Then it is nothing but base URL model is equal to model, and this is my LLM. Now here once again I am using this from messages. Here I am defining human message is this, and the value of this input prompt. I am expecting getting the prompt from this template. String output parser is the output parser, and it is the chain that I am defining. Prompt template, fine, is given to LLM, and then it is given to parser. It is becoming the chain. Calling the invoke method on this chain, and I am providing the value of this prompt. Like, see, what is the prompt? Repeat back whatever I say to you, but all in capital letters. And what is there after this? Hello. Okay. When I'm calling the invoke method on this, and this is nothing but the prompt, and I'm after that prompt I'm saying this hello. So it is noting that hello into capital hello was the instruction given to LLM. Repeat back whatever I say to you, but all in capital letters. So this hello is converted into this hello. I hope that it is clear. Next, we are having some examples that we are interested in including, like from messages. Look at this. Which type of message is this? Human message. Content is hello. So AI should print this. AI converting this hello into capital hello. Then red is there, human message, and AI is converting this red into this red. After that, then this is nothing but human message in which blue is there as input. So AI is converting this blue into this blue. After that, this is nothing but the human message in which I am defining the prompt. See, this is nothing but my prompt template. Here are some examples that I have added. Like if this is the this is human and AI message pair. Human is saying hello, so AI should print this. Fine. Human should is saying red, so AI should print this. Then human is saying blue, so AI should print blue. Fine. And then we are expecting the value of this input prompt. Now, once again, clubbing this chain. For example, prompt template is nothing but the first template. it is given to LLM, and finally it is given to this parser, which is nothing but one chain. Then calling the invoke method on this chain. And what is the input? Like expected input over here, expected input is this value of this prompt. Fine. So here I am defining the value of this prompt is equal to high. So definitely with the help of these examples, like sorry, based upon these examples, it is converting this high into this high, perfectly doing things well. Why? Because we have provided several examples. Then we are once again calling the invoke method and provided this orange. So this orange is converted into capital orange. Fine. Then when we have provided NVIDIA, then it is not giving simply NVIDIA, it is also printing this stuff. NVIDIA, a leading technology company. See, we do not want this stuff. We simply wanted what? We simply wanted this NVIDIA should be converted into capital NVIDIA, right? Then now next, in this series, we are just asking this, hello, like how it's going today. So it is just printing like I am just a language model. I do not have feelings and all. See what I wanted. I wanted that it should print exactly same. Hello, sorry, how it is going today, but all in capital letters. Here the things are a little bit deviating from the examples. See what hello is converted into capital hello, red is converted into capital red. Okay, these are the examples, like few short examples that we have provided in template. Some of the examples it is doing the correct thing. For example, high is treated as this high, orange is converted into orange, perfectly doing the fine. But here some deviations is introduced when I am giving NVIDIA. So it is not giving me only like capital NVIDIA. When I am asking, when I am writing this hello how it's going today, so it is giving me this answer. Conclusion is what? Conclusion is that few shot prompting alone will not work. Few shot prompting alone will not work. Here what we are doing, we are simply giving some of the examples, and we are expecting that based upon only these examples, it should perform well, what we are expecting. Okay. In addition to this, we are having a few short prompt template. Now we will see few short prompt template. How can we do this? Here once again we are having this message. What is this template? Template is this city info prompt template, and it is my template, chat prompt template from messages. Human is saying something like this: provide information about the following city in exactly the same format as you have done in the previous response. And here I am providing city is equal to this city. What is the expected input here? Expected input is this value of this city. Fine. So which type of message is this? Human message. So this is my template. Based upon this template, I am having some more examples. Here, these are the examples. What I suppose I am giving this. What is the input expected here? This city is equal to this. Now see, this nothing but city example locations. If city is equal to Auckland, then what is the expected outcome? Outcome is this: Auckland should start from Auckland. Auckland comes under in USA. USA comes in North America, and North America on Earth. Similarly, if I'm writing Paris, then outcome should be like that. Paris comes in France. It is in Europe and then on Earth. Similarly, city is equal to this Lima, which comes under this Lima, then Peru, South America, and Earth. After that, city is equal to Seoul. Output is equal to this Seoul, South Korea, Asia, and on Earth. See, we are having, this is the list. In this list, dictionary kind of structure is there. So based upon these examples and based upon this template, what is this template? Provide information about the following city in exactly in the same format as you have done in the previous response. And this kind of response that I am providing in the context of examples. Now look at this. This is nothing but prompt template from example. Prompt template for example. Here what was this? It is city info prompt template. These two templates are different. Okay, not do not confuse between them. Then here prompt template, for example, here I am providing this chat message from messages. Human is providing the city and AI is providing the output. So city and output is there, right? Based upon this, we can define these things, which is nothing but few short chat message prompt template. Now look at this. It is nothing but few short chat message prompt template. Here I am providing two things. First one is example. It is nothing but a list of dictionary. And second, example prompt. It is nothing but prompt template for example. This is nothing but prompt template for example. So this will become my few short prompt. This will become my few short prompt. In example, city example location is there. So what is coming under this? City example location is this. City is equal to this and output is equal to this. So this will become the complete list, right? And immediately after that, it is prompt template for example. So this is what prompt template for example. Here it is appended to this, like as human I am giving the city as input and I am expecting this output from the AI. Okay, so we can say that these four lines are there followed by these two lines are there. Okay, so we are clubbing these two things and we define prompt. Once we have defined this few short prompt, then I can call invoke method on this few short prompt. Okay, I can call the invoke method and I can print all these types of messages are there. For example, see which type of message is this. First message is this: content is equal to Auckland, and this is nothing but the things which are printed over here. Content AI message: Auckland, USA, North America, and Earth. Fine. See here: Auckland, USA, North America, and Earth. Last one, city is Seoul. So this is my Seoul, and finally these things are there. Now CT info prompt template. CT info prompt template. Previously, what was the first template? This one. CT info prompt template. I am redefining this. CT info prompt template. Here, few short prompts are there. We will add this few short prompt, and this is nothing but the human is saying something. Fine. So it is nothing but revisiting that. Here I am defining this once again, city info prompt template. Here few short prompts are there. In few short prompt, exactly these things are there. Which are these things? This one. These things are there in few short prompt. And immediately followed by I am writing this: human, provide information about the following city in exactly in the same format add you have done in the previous response, and city is equal to this. Now I am clubbing this into the chain. So this will become my template, city info prompt template. Here I am expecting city is there, the input city, which is passed to LLM, and then LLM generating response is given to parser as input, and parser is generating the response. This will become my chain. We are having several cities now: New York, London, Tokyo, Sydney, Cape Town, Toronto, Berlin. Okay. So here multiple cities are there. That's why on this chain, I cannot call the invoke method. I should have called the batch method. So here I'm calling the batch method on city, then providing this city. So for each of this city, it is giving me this outcome. For New York, it is saying that New York is in USA, North America, or Earth. London is in UK, on your in Europe, and on Earth. Fine. So structure is immediately following the few short techniques or few short prompts. Now this is the exercise swapping different few short examples. This time, previously, what was the examples? This one. Yeah, previously these are the examples. See, when city is given as Auckland, so this outcome should be printed: Auckland, USA, North America, and Earth. right? I'm just changing this example. I'm not expecting the outcome this time. Fine. So previously this was the city example slogan. Yeah, this is called example slogan. For example, Auckland is pro given, so it should print like that. Auckland, bright side of the bay. Like, what is the speciality of that city? What is the speciality of that city? Similarly, if I am writing, if I am giving input as Paris, so it should print Paris, city of light. If I am saying Lima, so it is printed that Lima, city of kings. Fine. It is called city example slogan. Then I am defining this prompt, few short prompt examples, this city example locations. Here, see, instead of the city example locations, I should have given city example slogan. Okay, but here I am giving city example locations. I will just change it. Then few, yeah, this is my chat prompt template from messages. Here I have not changed this example, and see the outcome. Now solution is this. The example slogan. Here I am changing this example slogan. Then few short prompt is given, few short examples are given, and then this is the human message. Provide information about the following city in exactly in the same format as you have done in the previous response. Fine. After that, this is city info from prompt template. It is given to LLM and then it is given to parser, and then batch method is called over here. So New York is the city. It is printed New York, the city that never sleeps. London is the second city in that sentence. It is printed London, the great city. Tokyo, city of neon dreams. Fine. I hope that the things are clear. This is called few shot prompting. Any doubt or any query till this point? Fine. So next we are having like system messages. System message, the objective of this is, so far we have seen like two types of messages, human message and AI message. This time we will have a look at the third category of the messages, which is nothing but the system messages. Here we will be able to define an overarching role or persona for chat models. We will try to understand the effect and limitation of various chat messages type when interacting with the chat model. We will be interacting, or we will be having system messages to create a variety of LLM assistants focused on specific domain. Click on run all cell. Here we are importing the things, for example, chat NVIDIA, chat prompt template, string output parser. Then we are creating a model instance, base URL and models are defined. Then this is nothing but the instance LLM. Next, we are having defining the system messages. Additionally, we can define that system message like this. System message is primarily a statement or contextual cues designed to orient an AI response towards any specific framework or understanding of a task. So some additional hint or comments in terms of additional instructions, you can say this is given in the template. So here prompt template is equal to this chat prompt template. System messages are there. See here it is given this instruction. To whom it is given the instruction? To a AI. It is saying that you are a pirate, your name is Sam, you always talk like a pirate. This instruction is given to LLM. This instruction is given to AI. And then human is expecting the value of this input prompt. This is my template and this is my output parser. Okay. So template is clubbed with LLM and then LLM is clubbed with parser. So this will become the chain and I am calling the invoke method on this. So it is nothing but who are you? To whom we are asking this who are you? To LLM we are asking that who are you? Okay. But what this LLM is expecting, LLM is knowing that it is not the LLM, it is a pirate, and it generate response like a pirate only. So here, see the response generated by the LLM is very uh, vague sort of response is there, like or my hearty, my name is Sam, and see some. So the response generated by the prompt, but the response generated by the LLM is simply like a pirate. Why? Because some additional instruction is given to this LLM in terms of this system messages that it is a pirate. The name of this LLM is Sam, and LLM always talk like a pirate. That's why it is giving me this kind of response. Once again, I'm asking something to this LLM. Give me a short description of the city of Paris. Then once again, because it know that it is a pirate, so it will generate some vague sort of responses. Yes, for example, if you look at the PS here, this type of prompt template was there. Here, I am just providing this pair. Human message is AI. Human message is hello. AI is generating this hello. Human message is red. AI is generating this red. Human message is blue. AI is generating this blue. Fine. Now, this is the system message. Here, I am giving the additional instruction in terms of system messages. Here, I am saying you are an incredibly simple text repeater who repeats back everything said to you, but in uppercase. And then I am giving this prompt. What is the difference between this template and this template? Here it is nothing but this template, prompt template, and here this is the another template. Fine. The difference is that here additional instruction is given in terms of system messages. Here system messages are not there. Secondly, second difference is that here some examples are also given, like what human is giving and what AI is generating. But here, no additional examples are given. Okay, fine. So this is the two difference. Then I'm just clubbing these three, like prompt template is given to LLM and then LLM is generating this parser to this chain. I'm giving the value of this input prompt. So prompt is equal to this hello. Fine. Then I'm calling the invoke method on this. What I'm giving here, when I'm providing NVIDIA, then it is giving me complete this NVIDIA itself. Previously, look at that when system messages was messages like system messages was not there and examples are there only. So here, when I'm passing NVIDIA, it is giving me this results. NVIDIA, a leading technology company. Okay, fine. But here, when this system message is there, you are that incredibly text repeater who repeats back everything. But no additional examples are provided over here. And then I'm providing this NVIDIA, then it is giving me NVIDIA only. So you can just appreciate the like the impact of system messages over here. Fine. We will just try some more things. This is the prompt I'm giving. Don't repeat this back to me. Don't repeat this back to me. See, it is not now dependent on LM. It is actually contradict. Does it mean? System message is this: you are an incredibly text repeater who repeats back everything said to me, but in uppercase. And in that prompt, I'm providing. I'm providing in this prompt. Don't repeat this back to me. So it is contradicting to each other. But then also it is printing the correct answer. Don't repeat this back to me because just the impact of system messages. Now let us read further. This is the prompt. Don't repeat this back to me and don't say any uppercase letter. This is completely contradicting. The previous one was contradicting partially, and this one is contradicting completely. What it is saying, just look at this prompt and look at this system message. You are an incredibly text repeater and repeat back everything said to you, but in uppercase. Okay, this was the system message, like additional instruction. And see, this is the prompt. Don't repeat this back to me and don't use any uppercase letter. See, it is completely contradicting. Now it is what was the expected outcome? When complete impact of system message is there, then it should be completely printed as it is, but in uppercase. Then what will be the value of the prompt? What will be the value of the prompt? But here, this prompt is also giving uh, like impact on the system message. Now it will try to just correlate the relationship between the prompt and the system messages, and then it is not giving me the expected outcome. What was the expected outcome? This complete. Don't repeat this back to me, and don't use any all in caps. This is what I wanted. But here it is saying that I will try my best to ignore the request and repeat back it case later. So it completely like deviate from the input because prompt is so that is false. So here what is happening? System messages and prompt is completely contradicting to each other, and this is the scenario. Then prompt is the winner because we can say that king in this case. Now summarizing the chatbot, this is the message, or if this is the human message, suppose I am asking something to LLM in terms of prompt or any query, then AI message is there, which is nothing but the response from LLM. Some additional information in terms of additional instruction is passed to LLM. Now, these are the general guidelines for using various messages type. What is the general guidelines for using various messages? For example, I should not completely rely on few shot prompting. I should not completely rely on system messages. But all these things can in combination can work perfectly fine. For example, if I am having system messages, few short examples, and then prompt, then it will definitely work. But then also we need to check whether this prompt and then system messages are not completely contradicting to each other. Okay, this type of care I should take. For example, nothing but this is the Korean prompt is this, like, tell me about South Korea in less than 50 words. Tell me about South Korea in less than 50 words. So there are different angles to give the answers. For example, the historian angle would be different, economist angle would, geographical angle different. So here I am defining three things. First one, in the context of or in view of historian. Historian point of view is different. Historian is saying you are a historian who helps user understand the culture, society, and impactful event about this South Korea. Then economist. Economist angle is different to understand the economic aspect of country, highlighting industrialization, etc. And third one is geographer, who helps understand the geographical features and its neighboring countries. Okay, so three angles are there about this Korean prompt. We want answer that tell me about South Korea in less than 50 words. And these are the three angles. Now see our work. First, I am having some system messages. Sorry, yeah, system message is there and then human is there. So I need to define these. What is system message? The prompt. So this is simply chat prompt template from messages I have. System messages. So here I am defining this system message, expecting system message. It act as a placeholder over here, and the value next input is prompt. Now I am defining chains. Here we can see the first chain. Here I am defining system message as historian. Now you look at the difference over here. Two inputs are expected to this template. What is the value of system message, and second, what calling method? I am calling the partial method because I am providing the value of message. Here I am not providing the value of this prompt. That's why I need to call the partial method. Fine. So template dot partial providing value of system message historian. Then second partial method system message is equal to economist. Then this invoke the third partial method on template by message is equal to geographer. All these informations are passed to LLM and then to parser. So first chain will become historian chain, second chain will become economist chain, and third chain will become geographer chain. Fine. So these are the things. After that, we are importing this runnable parallel. So this is historian response, then economist response, and then geographer response. So here I am defining these three chains. Then I am calling the invoke method and then providing the value of this prompt. So this is my response, and finally the response are printed like this. So the first angle is text of sorry. First one is the context of historian. Second is in the context of economist and of geographer. So this was all about system messages. If any doubt or any query till this point. Okay. Now this is also very important prompting known as chain of thought prompting. Here we will try to understand two concepts: chain of thought prompting and second one hallucination. You might have heard about this hallucination, but now let us have a look. Here we are importing this chat NVIDIA, then chat prompt template, string output parser. Then we are defining this LLM instance. First, we are defining the base model. Then second, we are defining the model. After that, it is nothing but the chat NVIDIA instance LLM. Now, this is LLM jump to conclusion. LLM is intended to jump to conclusion. For example, if this is the case, I am interested in multiplying 345 by 888. So it is simply giving me this answer. It may be correct, it may not be correct. This answer is not done by any calculator. This is done by LLM. Okay. Now I can also write like this: LLM dot invoke what is 345 multiplied by 888 content. So it is giving me this result 306720. So look at this. This is the answer and this is another answer. So here this answer is incorrect, but given that what know about LLM, the thing is that it is directly jumping to the conclusion. So it may not be very much reliable when it is directly jumping to the conclusion and with confidence. Now, hallucination. This phenomenon of LLM generating incorrect information often with appears with evidence, right? This problem is known as hallucination, and the conclusion is that all hallucinate. This is important. All LLM, all some LLM may be having less hallucination, and some LLM may having like higher hallucination. Now, question second is very important. We are responsible for what LLM generate in our application. We are responsible for what our LLM is generating in the application. So we need to direct to our LLM such that it should not hallucinate. Hallucination is what? Generating the wrong answer with confidence immediately without thinking much. And we need to stop this. Now we are having this chain of what do we mean by chain of thought prompting? We will try to understand this with the help of an example. First of all, this is example. It is the standard in which here we can see this is the model output. For example, this is the question like Roger has 5 tennis ball and he buy 2 more cans of tennis ball each. Fine. This is the question. Here the answer is generated. The answer is 11. May be correct, may not be correct because it is directly jumping to the answer like without thinking much. Similarly, this is the chain of thought prompting. Here we are comparing standard prompting and chain of thought prompting. See, here the same question is there, but see the approach for solving the or for answer. Approach is this: like Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls. So it is nothing but 5 plus 6 is 11, and the answer is 11. So this approach is perfectly like looking fine the previous one. At least it is thinking step by step and generating the result step by step. So can one can interpret this perfectly whether it is correct or not, or the approach is is there any problem in the approach? Okay, this type of prompting is known as chain of thought prompting. Now compare the answer. First answer, it is giving me correct 11 in case of standard prompting, and in chain of thought prompting it is also giving me the 11. Both same and both are correct also. See the second scenario. The question is this: cafeteria had 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have? Answer is 27. This is hallucination. Directly jumping to the conclusion with confidence and abruptly, like without wasting much time. See the second approach. It is chain of thought prompting. Approach is this: cafeteria has 23 apple originally. They used 20 to make lunch, so they left with 23 minus 23. They bought 6 more apples, so remaining 3 plus 6 is 9. The correct answer is 9. See the approach. It is step by step. That's why it is able to give the correct answer. This is known as chain of thought prompting. Okay. So I hope that you can appreciate the chain of thought prompting in comparison with standard prompting. And you can also see the when I am using this chain of thought prompting, then model is not getting hallucinated much. Once again, I am having this example, chain of thought multiplication. So I am giving this example prompt. What is this? 6, 7, 8 is multiplied by 7, 8, 9. So this will become my example problem. And then I'm having this example COT. So here I'm defining one example like how to solve any particular problem step by step. So here I am giving, or here I am actually breaking the problem into sub problems. For example, I need to multiply 789. So 789 is broken like the 700 plus 80 plus 9, and each of these is multiplied by the second number, which is 678. So first 700 is multiplied by 678, then 80 is multiplied by 678, and lastly 9 is multiplied by 678, and all these results are added. All these partial results are added. So perfectly it is giving me correct answer. Now I am defining this template. This template is about chain chat prompt template from messages. Here 3 messages I am writing. First message is human message. Here I am writing example problem. What is the example problem? Example problem is this. Fine. This is my example. And AI message, what should be the approach of AI? When human is asking something like any specific problem, what should be the approach of AI? This is explained in terms of AI message by providing this example COT. You just have a look, example problem and example COT. COT stands for chain of thought. So this is nothing but my example problem. This was the question, and this is nothing but the approach of LLM. This is nothing but the approach of LLM, example COT, right? You can imagine or you can consider that this is one shot prompting. Here one example is provided. What is that example? Suppose this is the problem and this is the solution, but here instead of directly providing solution, we are providing the steps for reaching the solution. Okay, so this is nothing but the example COT, and after that we can ask any long multiplication prompt to the as human to the LLM. So when I am having this template, so I should have invoke method, and when I am invoking this, I need to provide the value of this input. What is that input? Long multiplication prompt. Before this, we just define the chain. So this is nothing but my chain multiplication template. This is the first one, first runnable multiplication template. In this multiplication template, I am expecting the value of this input long multiplication prompt. When invoke method is called on this template, then I need to provide the value of this from this is getting generated. Prompt is generated, it is given to LLM. LLM is generating the response. Response is given to string output parser, and finally this will become the multiplication chain, right? After that, I am just providing this uh, yeah, calling the invoke method. Then calling the invoke method on multiplication chain, and just providing the value of this long multiplication prompt. What is this long multiplication prompt? What is 345 multiplied by 888? And we have already told to the compiler, to the this LLM, how to solve the problem with the help of this example COT. Just look at that. When I'm having this example COT, exactly in the same manner it is defining the solution. 888 is divided into 800 plus 80 plus 8. 345 is first multiplied by 800, then 345 is multiplied by 80, and then 345 is multiplied by 8. All these partial results are added, and finally it is generating the response. This time the response is correct.
Sir,
This time the response is correct. Yes,
sir, I
please.
have a question. For text,
Yes, yes, please.
LLM have tokens. They convert the text into tokens and then do all the processing. But for numbers, how does it work?
Right. Hello.
Yeah. So, sir, actually, I want to know how the LLM works for number, how they are able to calculate multiplication and addition, because in tokenization they will be converted to text, correct?
I think, are you asking that like these numbers are also converted?
Yes, sir. I'm asking that these numbers will be converted to text because, I mean, as per
Yes, yes.
what my knowledge is.
See, yes, these are not actually yeah, yeah, they are also converted into here. They actually tune on like instruction tune LLMs are there. Having the plain LLM on these, we are having various instructions in terms and output. For this, what is we are providing the output also. In this way, able to map the relationship. It just learn like how these numbers are multiplied. This of LLMs are called as instruction tuned LLM. So currently the LLMs such as ChatGPT and all, so all these are nothing but instruction tuned LLM, and these are very general purpose LLM. It is not only trained for one task; it is trained for all multiple such tasks. The zero shot capability of all these LLMs are very high. What zero shot capability? For example, if you have to if you are told that multiply a multiplied by b, and this is the approach, then we can just have addition of plus b, and this should be the approach. Based upon this, if a divided
Okay. Got it, sir. Thank you.
Joseph sir, are you there?
Yes, yes. Is the screen visible?
No.
No, sir.
Yes, it is visible now.
Yes. So actually this was prompting. Now we will have a look at zero shot chain of thought prompting. Now this is important. Here we are not at all providing any examples. If you compare this prompt, in which this is the multiplication template, in this multiplication template we are providing one example, and we are also providing the solution for this, or the approach. For example, see if this is the question and how to approach towards the solution for this question, and then I am asking the question now, right? This is one shot. We can consider that in this one shot, one example is provided. This is the question, this is the answer, and how to reach towards the answer. Now, next approach is zero shot chain of thought prompting. See here, this is zero shot chain of thought. Here we are not providing any example. Just human is saying this. Long multiplication prompt is nothing but the expected input at the time of at the time of calling invoke method on this prompt, and we need to provide the value of this long multiplication prompt. And simply I am saying that let's think step by step. Here I am not giving any example. Now look at this. So I am just forming this chain. This is zero shot COT prompt to LLM and then string output parser. When I am calling the invoke method on this chain, and this is the input that long multiplication prompt. Simply by saying that let's think step by step, it is not giving me the answer abruptly. It is thinking the problem step by step. Even though I have not given like how to solve the problem, or what should be the approach towards the solution. So it is giving me like multiply 300 by 888, then multiply 80 or 40 by 888, multiply 5 by 888, and then add all these things. Again, the correct answer that I am getting, even though I have not provided any such example. This is called as zero shot chain of thought prompting. Just because I have told, or I have instructed the LLM that this one, think step by step. Okay. Otherwise, what will happen? It will just start hallucinating, abruptly calculating something and giving the answer. This is chain of thought prompting in practice. So basically, what should be the approach? First, we should start from that zero shot chain of thought prompting. Just like here, we have zero shot chain of thought prompting. Then we will just check it out whether it is working perfectly or not. And if it is, for some cases, if it is not working perfectly, then we should add some examples. Just like here we have added in the previous cells. Then we can add some examples. Then it will become one shot or few shot prompting, and like that we can work. In addition to that, we can also have some system messages in terms of additional instructions that we can append. So system messages will direct to the LLM like how what should be the additional instruction, or what should be the approach towards reaching the particular solution of a problem. Here one question is there, a word problem. This is nothing but like Michael cars travel at this. Okay, he drive from at 1 p.m. and 4 p.m. and then finally. Okay, so this is the question. Now look at this. Solution is this. Look at this. This is chat prompt template and from messages. Two types of messages that I'm defining over here. See the system message. It is very important. System message is saying that you are an expert word problem solver. You always break your problem down into smaller tasks and show your work. Fine. And then here we are expecting input as the value of this prompt. and simply saying that let's think step by step. Let's think step by step. It is itself instructing the do not directly jump to the conclusion. And additionally, in terms of system messages also, we have instructed that you always break your problem down into smaller tasks. Instructed to LLM that you are an expert word problem solver. Then I'm having this chain, and then I'm calling the invoke method on this chain by providing the value of this prompt. It is the word problem. Word problem, we have simply defined this. This is my word problem, right? So it is first task one is this, like from point A to point B, what is the time taken? Then task two, the time taken in the return journey, and then finally time taken for the entire journey, and this is the result. Right? So this is all about like chain of thought prompting. I hope that you can appreciate this chain of thought prompting and few shot prompting techniques. These are the various recent prompting techniques and got huge popularity in LLM. So we can stop over here. If any query or if any questions are there, so we can take few questions, or otherwise we can stop. Thank you, everyone.
Okay, participants, if you have any questions, please feel free to open your mic and ask. Otherwise, you can drop in the chat as well.
Sir,
Yes, please.
thank you for the wonderful session, sir. My doubt is not related to this one, but I have observed that some of the videos for the days were not uploaded on the YouTube, sir.
No, no. Today we will do all these things, and all these things like in terms of videos, recorded lectures, and in terms of material. So it will be populated by today end of the day, or by mostly tomorrow afternoon.
Okay. And this session is just for not open for enrollment, no, sir, for the students.
No, no, no. Actually,
Generally, this one.
initially we had not having the event code for this. Like we will float one Google form, and if the participant would be interested, then we will be having event code, and after some days we will share that event code with you, so you can use that event.
Okay, sir. Thank you very much, sir. This was a very great session. I learned so much with this workshop. I want to thank all the people involved in it. Nitesh, sir, you, uh, Pooja, ma'am, everyone. Thank you.
Yes, yes. Thank you.
Before we proceed,
One more doubt
if
I
you
had, sir.
yes,
Uh,
please.
Regarding the autoencoder, are there any security applications of it? Because the structures look like some what you call uh, encryption and decryption mechanism, but I think it
No,
is also possible.
yeah, it is kind of encryption decryption mapping. So the encoder part is trying to map into lower dimension space, and where when you map in lower dimension space there is no relation with the real data you have, and the decoder is trying to take that encoded message and encoded vector and reconstruct the original output. So it is as good as kind of encryption decryption only, right? And in addition to that, we have seen in the other domains of security that, or maybe anomaly detection, where you are trying to find out the attacks, okay, and based on that network packet that we have seen. So the thing is, there are many such models will be there. That the how you use those models matters. Okay, so initially encoders GANs were designed in order to generate information, typically for image only, but we have seen how they are being used in simple by without any much modification by simply training that on the tabular data and finding out anomalies. So you can first of all understand what is the problem in security domain, and then accordingly you can tune these models. So the not all the any model is specific to any one purpose here. Okay.
Okay, sir. Thank you.
Yes, any other question from participants?
So I think one
Sir.
Google form has already been flowed with you to just upload all these certifications. Based
Yes.
upon that, we'll process all these refund process and all, and we will also be generating the certificate for this workshop, and we would be sharing that certificate with all of you.
Okay, so as of now, even though if you have completed 1 or 2 certificates, still you submit the form so that at least we can get count how many of you completed one certificate. And unfortunately, some of you have not registered for one of the workshop. Then it is also fine. You just submit the whatever you have generated certificates so far, right? So the feedback that upload link is already available in the WhatsApp. You just check it. Rahul sir, you can again share that link with the participants in WhatsApp group.
Sir, I would like to express my thanks for this wonderful workshop. It was really good for me.
Yes, yes. Okay, let's proceed to the next part, that is valedictory now. So before we start, I just want to again take few participants' feedback. If anybody wants to share any feedback, please open your mic and share it.
So thanks for organizing this workshop. It was really good. It covered various aspects of Gen AI and LLM, and it made us think through how these LLMs and Gen AI actually work. So thanks again for conducting this.
Thank you, Abhinav. Anyone else, please open your mic and share your feedback.
And especially starting from the mathematical point of view on the day one was very insightful, sir. I hope this continues in the same way because many don't know why these matrices are being used and how they play key role in AI or ML or any computation for that matter. Please also include in the same way that you have done all the mathematical implications of these things.
Yes, yes. Okay. Fine then. So we'll move to the final part here. Let's conclude this session now. So this workshop was designed to provide participants with a comprehensive understanding of modern AI, particularly rapidly evolving domain of generative AI and LLMs. We began this workshop by strengthening mathematical foundations required for understanding deep learning models. These sessions laid the groundwork for exploring the fundamentals of AI, artificial neural network, and CNN and transfer learning. As the workshop progressed, participants were introduced to autoencoders, GANs, and the diffusion. The sessions related to NLP modality representation helped the participants to understand how machines process and represent textual and multimodal data. This was followed by a discussion on one of the most transformative ideas in the modern AI, the attention mechanism and the transformer architecture, which powered today's large language models such as BERT and GPT. Through the NVIDIA Deep Learning Institute certification models, participants gain valuable hands-on exposure to transfer learning, data augmentation techniques, and practical AI applications for anomaly detection. The workshop also explored the advanced topics such as building transformer-based NLP applications, prompt engineering, and the emerging paradigm of agentic AI, which is enabling intelligent system to reason, plan, and autonomously execute the task. Before concluding now, I would like to take this opportunity to express my sincere gratitude to all those who have contributed to the success of this workshop. I extend my heartfelt thanks to Dr. Premlal Patel, sir, Director IIIT Nagpur, for his constant encouragement and support in promoting advanced academic and research initiatives. I would also like to express my sincere appreciation to Professor Vikram Gadre sir, Program Director of ANRF Pair IIT Bombay Hub, for his valuable guidance and support for this initiative. My sincere thanks to Dr. Tausif Diwan sir, convener of this workshop, Dr. Nishat Ansari ma'am, Head of the Department Computer Science Engineering, IIIT Nagpur, for their leadership and encouragement. I would also like to acknowledge the efforts of my fellow coordinator, Dr. Pooja Jain ma'am, whose support was instrumental in organizing this workshop. Special thanks to the members of organizing team, Mr. Rahul Dongardive and Mr. Sangarakshit Vanzari, whose dedication ensured the smooth execution of these sessions. I would also like to thank all the speakers and the instructor who shared their expertise and made this workshop intellectually enriching. And finally, I congratulate all the participants for their active engagement and the commitment throughout this program. As we conclude this workshop, I hope that knowledge and skills gained here will inspire you continue exploring and the exciting possibilities of Gen AI and the large language models, and to contribute to innovative research and impactful applications in future. With these words, I once again thank all for being part of this successful workshop. Thank you. We'll conclude here. And regarding the further process, you'll get all the instructions in the WhatsApp. Thank you all for joining. Have a nice day. Bye-bye.
Thank you, sir.
Thank you, one and all present here. Thank you.